So now that we're done with the blooper reel, let's stop. Nick, knock it off. All right, let's talk about 9.6. So 9.6 is old stuff, and there's a reason it's old stuff. But I put it to the end so that we could both feel like it was pretty easy and so that we could maybe know it for science class. So all 9.6 is the definition of a new word. Okay? Or a couple of words. Oh, so let me try this with an example from the morning class. So the amount of tri-tip, apparently there was something about Oakdale being like cowboy capital of the world that had to do with tri-tip.
What the heck?
So the amount of tri-tip consumed is proportional to population. Is this a believable statement?
Yeah.
Yes.
Totally. Do you guys have any idea what proportional actually means?
Yeah.
It's at the same rate as population, kind of?
Kind of, yeah. It's at like the same rate or something, but it's not really quite the same rate, right? It's at, the ratio is always the same, maybe? Right? So let me write down what it would mean for the ratio to be the same. You guys get to pick some variables here quick, so.
Batman symbol?
No. I'm going to have to draw this a bunch of times. So what are you going to call the amount of tri-tip?
Cows. Cows is fair, right?
How about a variable?
A.
Pig. T.
B. B for B.
Let's go for T. I'm going to go for T to be boring, and I'm going to avoid C for cow because of the close paren, open paren, C issue. Right? Let's see, what else is there here?
Population.
Population, what should we call population?
B.
H for humans?
Yeah.
Okay, sure, whatever. Pick a letter, it doesn't really matter. And then this is the word I need to define, right?
Yeah.
So what this statement means,
Something over something equals something over something.
yeah, really is that these two things, T and H, always have the same ratio. So I'm going to write that in a funny way, but really what we're going to think about is T over H is K. Or K is some constant. So what's the other way I could write this?
What's K?
Some constant. We'll see what we mean by K here in a second. It's called a constant of proportionality, which is really a fancy way of telling you how much tri-tip everybody eats. We'll get there in a second. What's the other way I could write this that wouldn't be scary fractiony? Yeah, T is K times H. Does that kind of make sense? So the way I would read this is the amount of tri-tip, right, T, is proportional, that's that K, that's the constant of proportionality, times H. Cool. So this sentence means this in math. Now you want to try the easy kind of problem for this and maybe understand K a little better? Okay, so the next sentence, right? This is like half of a word problem. It doesn't really tell me anything. So the next sentence, the one that asks me to do something, might say something like, if 10,000 people eat 2,500 kilograms of tri-tip, maybe not how much, but what's K? Right? What's that constant of proportionality? And remember, I wanted to do this late in the semester so it would seem really easy.
Quarter of a kilogram.
So, what do you do?
Divide 10,000
for T.
Yeah, plug stuff in, right?
H will be 10,000.
So
Be
2,500
is
equals
10,000 times K.
10,000 times K. Yeah, and then you just put it in the fraction, right? So divide both sides by 10,000. And yeah, if you want to just cram this straight in the fraction form, go for it. You guys with me? So what do I get? I get K is
4.
1/4, right? What are the units on the quarter?
Oh, jeez.
Kilograms? Close. That's this one, right? That 2,500 was in kilograms.
Of tri-tip?
Yeah, kilograms of tri-tip, right?
Kilograms over people per person.
Per person. You guys see that? I took kilograms and I divided it by 10,000 people, so my answer that I'm getting is kilograms per person. So what's a 1/4 is K tell you? What? Tells you that a person needs about a 1/4 kilogram of tri-tip, right? I don't know. Is that a lot?
Yes, 2
2.2
pounds.
kilograms in a pound, isn't it?
Yeah, 2.2 kilograms in a pound. Wait, the other way. A kilogram is 2.2 pounds.
Kilograms.
So,
Or 2.2 is.
Wow.
yeah, so maybe if I said K is about 2 pounds per,
Person.
not person. I replaced the 1 kilogram with 2 pounds,
Oh,
right? Per 4 people. Right, so that's a 1/2 pound a person. Does that seem like a lot?
Hell
It depends on how much you like tri-tip, right?
no. Yeah.
I can count like
Okay.
10 pounds in one sitting. If
You guys see this?
If you're with a bunch of
So keep in mind, right, that this, because 1 kilogram is about 2 pounds.
Oh, gosh. I'm burning.
So the thing I want you to keep track of is that regardless of how I measure tri-tip, right, this statement about the amount of tri-tip consumed is proportional to the amount of people. It doesn't give a crap how you measure tri-tip, right? The only thing that's going to change is that K. This gives me a nice, easy way to convert between different units, right? I can say this statement that's unitless, and then if I want to tell you how to solve, I need to kind of give you some units and calibrate your scale. You guys cool with that? Another use for this maybe would be to say, like, okay, if this, what's K? Okay, we found K, right? Then we could ask another question. How much tri-tip for 800 people? Or how many people for what do you want to do, pounds or kilograms? Troy?
It's America, let's do it pounds.
Let's do pounds. I don't want to make another unit conversion. So, what if you had 20 pounds of tri-tip? How many people would you need?
Yeah.
40.
That's possible.
So, which way does it go? Should you be multiplying or dividing?
Dividing
40 people. Yeah, 40 people.
It's 4 people, or 20 people.
Yeah, you guys see this? 2 pounds for 4 people. So 20 pounds for 40 people. So another way you could do this, right, is you could go back to your equation that you have. You have T equals KH, and you know K.
Well, yeah,
Right?
about 40 people because it's not exact.
Yeah, I made a little rounding. Let's assume that it's exact. But I would say T is 2/4 H. And then which one here do I know? And then 20 pounds of tri-tip? I know
H.
that's a T, right?
Yeah, you know T.
And I'm looking for H.
H is 800. So you can just.
So these are two separate questions, right? On this one, I'll get H is 40.
Well, it's good. 20 into 800 is 40.
Wait, what?
20 pounds. 800.
Oh, sorry, here. You're doing this one. Okay, so this one you get 40
Yeah.
is T?
What?
What?
Huh?
Let's try that one. So, what do you write down? You write down T is yeah.
If I try to.
Okay, what's K?
It's 2 over 4.
Okay, so in kilograms or pounds, you have to pick. So 2 pounds. So this is 1/2 of 800. So you get T is 400. You guys cool with this? Yes.
You don't have 9.6 homework.
I know. I will. It'll be up in a second.
Oh, it's just
So I need one more thing.
one thing on 9.6.
So this is proportional, right? Is this, right? The proportion's always the same. I need one more example that tells you how to deal with what they call inversely proportional. It's okay, it's not bad.
Sure.
Yeah. So if I said something like the force of gravity it is. But all it is translating from word problem to statement. And these statements happen all the time in science because we want to make statements that are true regardless of how you measure. And the way you make these statements is with proportionality. So if I say the force of gravity on anything,
Mars.
let's go with an object on Earth, maybe.
Wow.
Although this is true, in fact, for other places. Okay? Well, almost true for other places. Is proportional to its, what affects the force of gravity?
Weight.
Size.
Weight.
Sort of is a 5-word for mass, right? Right, so as mass goes up, force of gravity goes up. Everyone's with that? Okay. What's the thing that you can do to decrease gravity?
Lose weight.
You can lose weight, or you can, yeah, increase the distance. You can go higher, right? So it's proportional to its mass and inversely proportional to, and this is where things get wacky, the square of its distance from the center of the Earth.
We're going to journey there.
Can you guys translate this into a math statement like that T equals KH one? It should be relatively straight. Wow, just about killed myself with the eraser. Should be relatively straightforward, right?
Force of gravity.
Okay, so what's your letter for force?
Yeah.
F. Okay. F equals. So proportional to the mass means I should have a what? I should have an m and a constant. So km. You guys okay with those? Okay, times m. Now it doesn't look like a kilometer. Okay. And what?
We have to do some for inversely.
Yeah, I need some.
Divided by.
Oh, that's a good idea. Divided by seems like the opposite, right?
Yeah.
Of proportional to. And what should it be divided by?
Distance.
Distance
Like center there.
squared.
Oh, distance squared. So this is kind of like the empty squared.
So I've got f is km over d squared. You guys see that? So the thing I want you to take from this is this inversely, right? Means
Division.
on the bottom, right? That's a division thing. You guys cool with this?
Inverse means division.
Yeah, inversely proportional, right, is instead of multiplying by it, you divide by it. Cool? Questions, things? Yeah, I'll assign it right after class.
You're gonna apply it?